Hello guys, can you hear me? I'm so sorry guys, I don't know if this stream was cursed or something, but issues were happening after issues and we're starting it with so much delay. Let me announce everywhere that this stream has started. Hi, I know guys, you are waited for a long time and all I can do is to have this stream in the best possible way so that it makes up for you. And I'm pretty sure that you're gonna learn a lot. Let me announce everywhere that let's get started and wait a little bit till everyone else join too. So how are you doing guys? Yes. Well, I think we have to discuss everything from scratch. Although, as I told you before, it's very good if you watch the topic stream that we had on number theory 2 before. If you have watched that already, it's gonna be very helpful and you'll learn everything way better. I wrote this for you in the Telegram channel that it's better if you do that. Have you guys watched that one? Or not? That's great, it's not terrible. I see. Watched? Nope. Yes, there is just one of numbers over, right? Hello, Shan. Hello, Amuse. Yes, the number theory number 2 is here. Let me show it to you guys. You can view it here. Let me see with my own. It's a bit. Let me move this and move myself a little bit as well. Okay. Now better. So. Okay. So the playlist is in here. You can watch all the topic streams in here in this playlist. You can, for example, watch the thing that I wanted you to watch was this one, number theory number 2. That it would help, but as I know that maybe some of you haven't watched it yet, I will start from scratch, but it definitely helps. How many topic streams have you guys watched already? For example, is it your first time? Sound is very low. Wait. I don't know why my setting automatically changed the sound. Get ready, it's gonna get high. So maybe you should reduce the sound of your laptop. Okay, how is it now? Is the sound fine? Hi, Gurab. Yes, nice that you know that it's morning in here. Usually people just say good night. I know that it's night or not night, but it's evening for most of you guys right now. Yeah, but here is morning. Can you practice problems after stream regarding the topic? Yes, and there was a contest about combinatorics as well before the topic stream. What is the meaning of combinatorics? I'm gonna tell you about this. So, too high. Yeah, you should maybe reduce your volume. Too loud. Yeah, I told you to get ready for this. Maybe let me make it a bit less loud. You don't have college on Fridays? Yeah, I have, you know, I have to go to the university on Fridays as well. But I usually, that's the reason that I try to put this as early as possible in the morning so that I can go to the university afterwards. And guys, today is a special day. Do you know about it? What is today? Why is this happening? Yes, what is your plans for Valentine's Day? What are your plans? Code, right? Watch your stream. I see. Thank you. Solve at least 10 CF problems. Sounds like a good plan. I see. I hope that you enjoy. Assalamu alaikum. Salam. Green Blitzcode. Nice. Learning about combinatorics. I see. Okay, so I think now we should start. Yeah, we can talk about that too. What is your full name? I'm new to your channel. Does anyone in here know my name? Know my full name? Yeah, I will do this stream from the basics, although as I said, it would be helpful if you have watched the number theory second one from before. Colors don't have Valentine, we have TLE. Shayan Jessam, Shayan Jahan, Shayan Chashp Hajjaj. Yes, that's right. It's Shayan Chashp Jahan. Sheikh. No. Yes, that's my complete name. No, I'm a PhD student in here in University of Maryland. I think people have joined by now, so we can gradually start the stream. No, in UMD, University of Maryland. You know some other people from UMD as well. Do you know some people from UMD? Who else do you know from UMD? University of Maryland. I participated last time in ICBC. Last year we were in World Finals. Exactly, Colin. Colin is also in UMD. We were teammates in ICBC. Also Sam. You might know Sam as well. The donut boy. No, I'm not from Indonesia. I'm from Iran, originally. We will talk about that. I will release the video about how to get to experts probably today, very soon. And it's gonna be a super video. I can show a preview to you guys as well today. Maybe I can show a preview to you guys. A teaser before it gets started. Yeah. Before I release it and before we start today. take a look at it. This is a
Hey guys, this is Cheyenne, and in this
of what you can expect. And there are parts of my interviews with other people in it as well, like Omnik, Arash, Alireza Kaviani. So it will be released very soon, and I think it's gonna be super helpful for you guys. So stay tuned for that. It's about how to get to experts, and if you are a newbie, a pupil, or a specialist right now, it's gonna be for you guys. Sure, I will do that. Okay. Thank you guys for the hearts. Let me give a heart to you as well. Thank you. So I think now we can start, and everyone who wanted to join, I think has joined by now, so we can start the live stream. Yes, it's about practice, but it's also important that how do you guys want to practice? Yeah, I can tell you how to increase your rating by 1. You should just participate in contests. I mean, that's all. If you're 1899, you will get 1900 easily as well. Just keep participating in contests. Yeah, I can do that too. So let's start the topic stream today about combinatorics. Ask Mike to catch jitters, then it will become 1900. That's right. I am failing. Now, have you participated in our II Arifin Fuad? So the topic that we want to talk about today, as you guys already know, is combinatorics. We want to see that what is combinatorics, learn it from the basics to advanced topics, and solve some hard problems, some problems that have high difficulty as well from it. So let's start from the first question, the first important question. That's, I told you it's good if you watch it from the second number theory topic stream as well. I'm gonna talk about it today too, very soon, but if you have learned it already, it's gonna be very helpful for you, so that you will be okay with this part already. So what is it? Let's start from this topic. Assume that we have two numbers, a and b, and we want to calculate a to the power of b. So we will be given two numbers, a and b, and we want to calculate a to the power of b. Since this number can be very large, let's calculate it modulo some mod. For example, mod is 10 to the power of 9 plus 7, for example. And a and b are both up to 10 to the power of 9. Okay, we want to calculate a to the power of b. A and b both are up to 10 to the power of 9. And we want to see that what a to the power of b is. Since this will be very large, we have to calculate it modulo some mod. So what is the best order that we can calculate this in? What is the best order in which we can calculate a to the power of b? What do you guys think? As I have also talked about it in the number theory topic stream. Exactly, in the O of log of b, I can calculate this. And how? Well, the point is that when you want to calculate a to the power of b, if b is less than, or if b is 0, let's say if b is 0, a to the power of b is going to be 1. Otherwise, there are two possible cases. Either b is even, b modulo 2 is 0, or b modulo 2 is non-zero. Or in other words, either b is even or b is odd. If b was even, I say that a to the power of b is gonna be a to the power of b half. We will calculate a to the power of b half, and we call it some number like x. We define x as a to the power of b half. And then we say that the answer is gonna be x times x modulo mod. Because a to the power of b is gonna be a to the power of b half times a to the power of b half. So we can just calculate a to the power of b half and just multiply it by itself. And then if b modulo 2 was 1, again we define x as a to the power of floor of b half or b minus 1 half. And then we can say that our answer is going to be x times a modulo mod. We can just multiply x by itself and then add an additional a2. Then we have a to the power of b. Because when we multiply x by itself, it's going to be b minus 1, a to the power of b minus 1. We have to multiply an additional a. So it's going to be a to the power of b. This way, also you have to be aware of overflow. Make sure that you won't have overflow. For example, if you use ints, you have to multiply a 1ll here as well. So to cast it to long. And 1ll just casts ints to long. If you have an int, by multiplying 1ll to it, it will be casted to long. And in this part, you had to add a modulo mod as well, in order to make sure that you won't have overflow. But anyway, what I'm saying is that I can easily calculate a to the power of b by calculating a to the power of b half. This way, you can see that each time b will be divided by 2. So we start with b, and each time you are making b into floor of b half each time. Again, next time it's going to be floor of b half, floor of that half, and so on. So this way we can say that this process, how many steps does this process take until b gets equal to 0? The number of steps is O of log of n, log of b, because each time b is divided by 2. First of all, I'm talking about the powers, 20. So also it's very easy to implement. You just define x as power of, you have a function that takes a and b and returns a to the power of b. In this function, you just say that if b was 0, return 1. I'm writing a pseudocode here. Else, if b modulo 2 was 0, just define x as power of a and b half and return x times x modulo mod. You have modulo mod as well. And then if b modulo 2 was non-zero, or in other words, it was odd, x again will be power of a and b half. B half, for example, in C++ is floor of b half. So this is going to be okay. And you will return x times a. And we will take care of mod as well. But guys, there's one important point. If we don't write it like this, that x is equal to power of a and b half, and in here instead we just return power of a and b half times power of a and b half. Does it work? Is it gonna work if we write it as power of a and b half times power of a and b half? I'm very good, Nesh, thank you. Does it gonna work? Is it gonna work? If we define it, if we define our power function like this, seems yes, no, it would not be log n, it ain't, it may work, but more steps will happen. Nope, yes, but it will run twice. The point is that our time complexity wouldn't be log n anymore, and it will be so slow, so it won't work, because it's gonna be so slow. It gives you the correct answer, but it's gonna be so slow. Why? Because it calls the function twice, yes, and it's not gonna be only twice. Again, each one of them will call 2 things. So next time we will have 4 function calls. Again, each one of them will call 2 things. So next time we will have 8 function calls, and so on. So starting from the beginning, nice. Getting to express. So you don't need the video that will be released very soon. This will be like this. We start from B and we will call 2B halves. And from there we will call 4B fourth. And so on. And you can show that the number of function calls in total will be of O of B this time, not O of log of B. So never do this. Make sure that you will never do this. Just save that in some variable and multiply it by itself. Make sure that you won't call the function twice, because it's not gonna end up as being twice. It's gonna be called over and over again. Each one of them again called 2 things. Each one of those things again called 2 things. But this way, each time we will call 1 thing. So because there are log of n, log of b values, it's gonna be of log of b. Okay, is it completely clear? If it is, please use this emoji, 100 emoji, or put a plus in the chats. So this is all about power. Awesome. Nice. And if you have any question, you can say that as well right now. Okay, so the next thing, exactly, log of n base 2. And we can also show that, in general, when we write Lg of n, it stands for log of n in base 2. Lg stands for log of n in base 2. Ln stands for log in base e. And when we write log of n without any numbers, it usually stands for log in base 10. So this is just notations. And when we write Lg of n, we mean log of n in base 2 in general. And we can also show that all these logs are from the same order. They are just some constants times the other one. The math is a bit complicated for me. Should I check some math videos to understand this? You can watch the number theory topic streams. Well, in general, I strongly recommend to you guys to watch all the topic streams. Each week we have one, so there are not much topic streams. If you just start each week, you can watch maybe 3 of them, and over several weeks, you're gonna get to where we are right now. So, I mean, even if you don't want to put so much time and watch 1 every day, you can watch, like, for example, 3 each week, and after several weeks, you will get to what we are right now. Try to watch all of them and watch them completely to make sure that you understood it well. If you didn't understand some parts, you can play that again to make sure that you understood it. It's gonna be super helpful that you get to whatever that we have discussed till now. It's gonna be super helpful for you if the math is a bit complicated for you to watch the number theory topic stream. Are we going to discuss the Sterling number? No, today we're not gonna discuss the Sterling numbers, and it's not very. Sterling numbers are not important at all in competitive programming. They're important in calculus, but not in competitive programming. You can find the binary representation of B. Yes, that's also. How long does this stream last? It's gonna be around 2 hours. It's gonna be around 2 hours. If it was necessary, maybe it can last a bit more, but in usual, the streams are set to be for 2 hours. Yes, sure. Yes, sure. I will create a problem sheet as well. Sure, I will talk about that as well. In the video, I exactly talked about that, how I got from newbie to experts in 3 months. Let me show it to you guys here. I was in newbie here in March of 2015, 10 years ago. It's been 10 years. And in 3 months, from March of 2015 to June of 2015, in June of 2015, I won rank 4 in a Div 2 contest. I got expert sooner. I got expert in May. So from March to May is 2 months. In 2 months, I got to experts from newbie. But I won rank 4 in 3 months. So I will tell you in the video that's what I've done in this period of time. And I will tell you everything that I believe you should do as well. And I always tell this to my students too. This is something that I believe you should do. You can do that as well, yes. If it was complicated for you, this topic, you can watch it afterwards as well. Yeah, you can do that. No, I was not a specialist. You know, back then, if you see that I was a specialist here, back then Codeforces rating was starting from 1500, not from 0. Back then Codeforces rating was starting from 1500. And if you see that I'm a specialist here, it's not because I was a specialist before. It's because the rating starts with around 1500. If you see it, in the first contest, I got minus 68. So in the first contest, I lost rating. I lost 68 because I was 1500 from the beginning and lost that. Back then, CF was like this. The average rating was 1500. So whenever a new user would come, their rating would be 1500 too, and they start from there. Okay, I will talk about those things. Okay, so let's move on to the next thing that we want to say. I'll answer all these questions as well. Well, the next thing that I want to tell you is combination. Combination. Well, what is combination? Well, in general, in combinatorics, combination, as the name suggests, is one of the most important things. Well, combination, when we write n choose k, it stands for the number of ways to choose k things, for example, k people out of n people. So it's the number of ways to choose k items out of n items, k books out of n books, or anything. So the question is that how many ways do we have to choose, for example, k people out of n people? How many ways do we have to choose k people out of n people? So let's see how can we solve this problem. How can we calculate the number of ways to choose k people out of n people? Well, my algorithm will be like this to choose k people. I say that I will order everybody. I will have a permutation on all the people. And then afterwards, I will choose the first k people out of them. This is my algorithm. I will order all the people in a queue, and I will choose k first people in that queue. This way, I will have n factorial ways to permute the people. In the first position, we have n choices for who stands there. In the second position, n minus 1 choices, and so on. In the last position, 1 choice. So we're gonna have n factorial choices. But is that it? So is the answer gonna be n factorial? Yes, there are problems involved as well. So is that it? Is the answer gonna be n factorial, or do we have any issues by calculating like this? We wanna choose k out of n. How many ways do we have for that? Why this opens again? Adds. I said I tell you that in the video for sure. Yeah, we want to calculate n choose k, but we want to see that what is n choose k. Okay, we don't know what is the value of n choose k. We want to calculate it. Exactly. We're gonna have overcounting. For example, assume that out of 5 people, we're gonna choose 2 people. Then if we order everyone like this, like 1, 3, 5, 4, 2, it's gonna give you 1 and 3. It's gonna give you 1 and 3. And also if we order them like 3, 1, 4, 2, 5, again it's gonna give you 1 and 3. So these 2 ways are gonna give you the same thing, but you're counting it twice, or even maybe more. Maybe there are even more ways to do this. So what can we say? Well, the point is that in this situation, we can say that when we order everyone and choose the first k people, for each way, how many times are we counting it? Can you help me with that? How many times I'm counting each possible answer? For each possible answer, for each choice of permutation and choosing the first k people out of it, how many times is that being counted? K factorial, so n minus r factorial times we will have the same set, n minus r factorial. What else? These are good suggestions, but they are not correct yet. They are not enough yet. So how many times we will calculate the same set? The same set of people will be chosen. K factorial times n minus k factorial. What do the rest of you guys believe? K factorial times n minus k factorial. What else? Do the rest of you guys agree with this? K factorial times n minus k factorial, or is it something else? I'm not going to give any comment if that's right or not. I want to hear more opinions. So how many times the same way will we calculate it? Yes, we agree. Thank you, Manas. The point is that, yeah, it's correct. Each case of choosing k people out of n people, if we permute everything, will be counted k factorial times n minus k factorial times. Why? Because in any way that you will put, consider that we have some set. We want to see that how many times this set is counted. In any way that we put it in here, put those k people in here, we're gonna have k factorial ways to put those k people here. And for all n minus k people that are not being chosen, for all these n minus k people, we have n minus k factorial ways. So for the first k people, we have k factorial choices, and for the rest, we have n minus k factorial choices. And in all of these ways, the k people that will be chosen will be exactly the same k people. For example, in this case, I'm gonna have 2 ways if I wanna have 1, 3 or 3, 1 in here, and 3 factorial ways or 6 ways to put 2 and 4 and 5 after them. So in total, I'm gonna have 2 times 6, 12 ways to put these people in a line such that at the end person 1 and person 3 will be chosen. 2 times 6 times 12 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 times 6 times So the point is that each case will be counted k factorial times n minus k factorial times. So I have to divide my answer by k factorial n minus k factorial, because each answer is calculated at k factorial times n minus k factorial times. So n choose k is going to be equal to n factorial over k factorial n minus k factorial. This is the reason that this is k, n choose k. Maybe many of you have heard this before, but you didn't know the reasoning behind that. This is the reasoning behind it. This is why n choose k is equal to n factorial over k factorial n minus k factorial. Okay. Do you guys agree with this? Awesome. Nice. If the rest of you agree as well, you can use this emoji, 100 emoji. Awesome, guys. Nice. We're gonna say a lot more things about combinatorics as well. The fun is just getting started. So things are gonna be a lot more interesting and fun. And guys, in case you're not against it and it's not gonna harm you in any way, I would really appreciate it if you come here and like the video by pressing this button. Liking the video, I think that helps me a lot. So in case it doesn't harm you in any way and you're not against doing it, I would really appreciate it if you can like the video or share it with other people. Invite other people to watch it as well. You can also click here to share the video with others. So you don't have to do it, but in case it's not gonna hurt you and you really like the video, I would appreciate it if you can do that. So let's continue. Now we want to talk a little bit more about this combination and see that. Thank you very much, Anonymous and Dreamer23 for liking it. Thank you. Even if anyone else has liked it, also you can tell me. I really appreciate it. I basically said something right. Set of numbers and permutations of a set are two different things. Yes, that's right. Set of numbers and the permutation of a set, yeah, there are two different things. That's right. So, yes, this is let me share the playlist with you guys. The playlist is in here. I mean, you can, let me show it to you. You can go to the playlist by going to you can click here, go to my YouTube channel, go to playlists and Friday's topic streams. And this is the playlist. You will get this playlist then. And we have all the videos of these topic streams so far. I share the link here with you as well. So, yeah, I'm releasing a video for you. I just said at the beginning of the topic stream today. So, let's continue. As I said, the fun is just getting started. So, I want to prove several things about combination. Several things that are very interesting. First of all, I want to tell you that how a combinatorial proof works on proving several things. I want to show that how combinatorial proof works. First, I tell you a problem. Let's say that we have n choose k. I want to say that for n and k greater than 1, greater or equal to 1, they are non-zero. I want to say that n choose k is equal to n choose n minus 1 choose k plus n minus 1 choose k minus 1. How can we prove this? I want to prove that n choose k is equal to n minus 1 choose k plus n minus 1 choose k minus 1. That was a very funny comment. Yes, I should change it to almost never on Friday. But today is on Friday. But yeah, I agree that usually it's not on Friday. You have to work on everything. You have to solve a lot of problems, and yeah, you can get better, definitely. Mathematically add and simplify. Brute force and count each individual element. Well, yes, there's exactly. There are two ways to prove this. One of them is algebraic, and one of them is combinatorial. If I want to show you the algebraic proof, that's this. Let's see that what we have in here. We have n minus 1 factorial over k factorial n minus k minus 1 factorial plus n minus 1 factorial over k minus 1 factorial n minus k factorial. And so in here we see that we want to make these denominators the same to add these two values. What is the same denominator that we can have? From here we can have k factorial. From here we can have n minus k factorial. And we have to multiply this by n minus k. So we have to multiply n minus 1 factorial by n minus k. So that, I mean, in here we want to multiply numerator and denominator by n minus k. And in here we have to multiply them by k, so that the denominator becomes k factorial times n minus k factorial. So we have plus n minus 1 factorial times k factorial. So what is it going to be? We have n minus k times n minus 1 factorial plus, sorry, not k factorial, plus k times n minus 1 factorial. Because we are adding, multiplying k by numerator and denominator. I'm going so much like this. It's not straight. Sorry for that. Anyway, so we have k times n minus 1 factorial plus n minus k times n minus 1 factorial. This is n times n minus 1 factorial. So it's going to be n over n factorial over k factorial n minus k factorial, which is n choose k. This is algebraic proof. With algebra, we prove that n choose k is equal to n minus 1 choose k plus n minus 1 choose k minus 1. Right? This is just algebraic. Is it clear? How do you feel about this proof? How is this proof? How do you feel about it? Well, I can tell you how do I feel about this proof. It sucks. It's so long, you have to write a lot of things, and you know, it's not good. But I have a very interesting and better proof that can solve a lot harder problems as well. And I want to tell you about that now. And that is called combinatorial proof. A combinatorial proof. I'm going to now talk about the combinatorial proof. First, I want to ask you, do anyone know the combinatorial proof? I think one of you said this in the chat. Maybe it was anonymous. But do you know first that can anyone say what is the combinatorial proof? Do any of you guys have any idea about it? Because the reason is that this proof is not good at all. I mean, it works, but we don't like it because we're used to solve the problems very beautifully and have great ideas. Yes, can you copy and paste it again in here so that everyone can see it? Or anyone else? Never choose last plus always choose last. Exactly. Well, the combinatorial proof usually is like this. We define a problem in order to show that two things are the same. We want to show that A is equal to B. We define a problem and then we solve it in two ways. So we define a problem and then we solve it in two ways. What's going on? We are showing that, Roman, we are showing that n choose k is equal to n minus 1 choose k plus n minus 1 choose k minus 1. So we define a problem and we will solve it in two ways. Yeah, I will tell about that as well. Okay, we will solve it in two ways. In one way, the answer is A, and in another way, the answer is B, A is going to be equal to B, because the same problem cannot have two answers. So if in one way the answer is equal to A and in another way the answer is equal to B, we can conclude that A is equal to B. So if in one way our answer is equal to A, we define a problem. If in one way our answer is equal to A and in another way the answer is going to be equal to B, it means that A is equal to B, because the same problem cannot have two answers. Okay? The same problem cannot have two answers. So if it's some way it's A, in some way it's B, A and B must be equal. So now let's do it on this problem. Let's see if we can define a problem such that on one hand its answer is equal to n choose k. On another hand, its answer is equal to n minus 1 choose k plus n minus 1 choose k minus 1. I define the problem like this. Let's say that we have n people and we want to choose a team of k people. We want to choose a team of k people out of n people. I say that I solve it in two ways. In the first way, I say that, okay, it's n choose k. That's very simple. The simple solution is that it's equal to n choose k, because that's the definition of n choose k. On the other hand, I say that let's consider these n people. Let's do a very great drawing. Let me become Picasso. These are our n people. Let's consider the first people or the last people, anything. There are two ways. Either this person will be chosen in our team or will not be chosen in our team. If this person will be chosen, first, if this person will not be chosen, if we do not choose this person, then we're going to be left with n minus 1 people, and we have to choose all the k people from those n minus 1 people. Or this person will be chosen. If this person will be chosen, we're gonna choose, we have to choose k minus 1 people out of the remaining n minus 1 people. So we're gonna be left with n minus 1 people and we have to choose k minus 1 people out of them. So we have these two ways. If this person will not be chosen, the number of ways is n minus 1 choose k. If it will be chosen, this person will be chosen, it's gonna be n minus 1 choose k minus 1. So we have these two ways, so we have to add them to get the final answer. So at the end, n choose k is going to be n minus choose k plus n minus 1 choose k minus 1. Yeah. Is it clear? I know that you're not PhD or anything. I'm not assuming anything. Was anything not clear? Yash once. If anything was not clear, let me know. So if anything was looking hard or was not clear, let me know. I'm just saying that n choose k is going to be n minus 1 choose k plus n minus 1 choose k minus 1. N choose k is going to be equal to that. Yes, it's very intuitive and this is a beautiful solution. Beautiful proof. Yes, it's beautiful. Unlike the algebraic proof. That's why I said that the algebraic proof is not good. Because Combinatorics is way more beautiful than that. By combinatorial proofs, we can solve it in a lot better way. Well, because we are not gonna apply formulas. We are not going to apply formulas. We need to know that what is going on. We want to prove things. We want to see that what is behind things. Also, when I said n choose k, I could say that, well, n choose k is equal to n factorial over k factorial n minus k factorial. Just memorize it. But that's not how it works. In competitive programming, you have to comprehend things. You have to know that what is going on. You have to make your brain work better on the problems. That's why we want to try to find out what is going on behind the thing. So I didn't say that, yes, n choose k is equal to n factorial over k factorial n minus k factorial. I tried to get there. Also in here, I tried to get here. I didn't apply any formula that, yes, these two are equal. Right? Yes, exactly. This is amazing. Great. I'm so happy that you are learning a lot, Ape. So, again, if it doesn't harm you, if you like the video, I would appreciate it if you like it from here. That would definitely help. But if in case it's not gonna harm you. But then you have to derive n choose r also. Yes, I have derived it already. I've calculated n choose r already. I know that n choose k, I showed that it's equal to n factorial over k factorial n minus k factorial. Exactly. That's why I said combinatorics is very beautiful. Unlike the algebraic way, that was not very beautiful. What's the proof of n choose k? I said it in the video. I said that if we want to choose k people out of n people, I say it very quickly because I don't want to repeat it for everyone who were present. I said that we permute everyone and then choose the first k people, but we will overcount. How many times we count every choice? The number of ways that we count every choice is k factorial, because in any way that you put those k people at the beginning and n minus k people after that, in all of those ways you will get the same answer. So it's going to be n factorial over k factorial times n minus k factorial. P and C is, yeah, I don't know. Well, to my eyes they are very beautiful, and as I see for many people that I've seen, combinatorics in general is very beautiful. I mean, I really like combinatorics. Anyway, so now let's go to the next level. Let's make it to the next level. Yeah, it was beautiful if there were more combinatorics problems. Let's calculate this. Let's calculate sigma of I from 0. Oh, and I forgot to mention that this equality is called Pascal's equality. That's what you were trying to say as well. This is Pascal's equality. This is famous. This is the famous thing. It's Pascal's equality. But we don't want to memorize it. We have proved it now. Okay. Are you asking me that from where did I learn? Or someone else? Now I want to calculate this. Sigma of I from 0 to n choose I. What is this value? What is sigma of I from 0 to n from I from 0 to n choose I? Pray you don't have to study actual research level combinatorics. 2 to the power of n, 2 to the power of n, 2 to the power of n, exactly. And what is the proof? Again, maybe we can prove it using very complex algebra. It's almost possible because now it's getting more complicated. You have to write a lot of things and add them up. It's gonna be very problematic. Or we can use induction to prove that. That's also a way. We can use induction to prove that. But there's also a better way. The combinatorial way. Can anyone solve it in combinatorial way? So we want to calculate I from 0 to n choose I. What is that? What is this value? Select a person or not. Each person is either included or not. 2 ways for each item. Yes, they are very good. Problem. Yes, that's exactly what I'm looking for. Choose any number of people so that for everyone we have choose or not choose that is 2 for everyone, hence 2 to the power of n. Yes. So, yes, let me, yeah. It's equal to 2 to the power of n. What? Why? Because I define a problem like this. Assume that we have n people. We just want to choose a team, and it can have as many people as it wants. We want to just choose a subset. Choose a subset. Or let's say we have n items this time. The story is up to us. We just need to define a problem and then solve it in 2 ways. Let's say we have n items and we want to choose a subset. How many ways do we have for that? Well, in one way, we can say that the number of ways is 2 to the power of n. That's very easy to say because the number of subsets of n items is always 2 to the power of n. For each one, it either comes or does not come. But on the other hand, we can say that this subset either will have size 0. Let's say this what the size is going to be. Either the size is going to be 0, in which case the number of ways is n choose 0. Or the size is going to be 1. In that way, the number of ways is n choose 1. Or the size is going to be 2. Or the size is going to be 2n. So the number of ways will be n choose n. So if the size is equal to k, the number of ways is n choose k. So simply, we can add all these values and say that the number of ways to choose a subset is the sum of the number of ways if we choose a subset of size 0, a subset of choose 1, or choose a subset of choose n. So on the other hand, we can say that the answer is sum of all these values. So the answer is going to be sigma of I from 0 to n choose I. And we see that, boom, that's the same thing as this. So in one way, the answer was 2 to the power of n. In another way, the answer is sigma of I from 0 to n choose I. Therefore, because the same problem was solved in 2 ways, and a problem cannot have 2 different solutions. 2 different answers. It can have 2 different solutions. It cannot have 2 answers. It has some ways. In one way, we can say that it's 2 to the power of n. In another way, we can say that it's also equal to sum of n choose I. So these 2 are equal. Is this clear as well or not? If it is clear, please again put a plus or use this emoji. Choose elements from, yes, exactly. Could you extend your topic streams, like bring more parts for a given topic? Yes, definitely. Each time in our Telegram channel, I recommend to you guys to join to our Telegram channel. You are more than welcome to join our Telegram channel. In there, I put a vote that what do you want the next topic stream to be on, and I will do whatever you decide. So for example, right now, if we are discussing combinatorics, is because, let me show the Telegram channel. Let me also send its link here too. You can join the Telegram channel from this link. This is playing. You can join the Telegram channel from this link. And if you look at it, the reason was that, and I also put a very great vlog of how it was snowing. Let me show this as well, I got distracted. Just look at how it was snowing like 2 days ago in Collegeburg. It was super nice. Anyway, the reason was that we had a vote here that you guys chose Combinatorics. 39% chose Combinatorics. So if you want, I can discuss this. For example, I can discuss combinatorics in another topic stream again. Next topic stream is gonna be during the week. As I said, this week I'm gonna have 2 topic streams since last time. Since last week we missed the topic stream, so I want to make up for that. So we're gonna have 2 topic streams this week. Probably I'm gonna have one on Monday, probably. Yeah, I don't know what combinometrics is really. Some people said combinometrics in the comments. So yeah, sure, alright. Okay, so this is how we can calculate sigma of I from 0 to n choose I. Now the next thing, I want to show that n choose k is equal to n choose n minus k. How can I prove this? Now let's see that if you guys have any idea on how to prove this. Why I wrote it so bad. So I want to show that n choose k is equal to n choose n minus k. Selecting k same as rejecting n minus k. Exactly. Yes, Matthew. Yes, selecting k is the same as rejecting n minus k. Exactly. That's completely correct. Also, we can say that their formula are the same as well. So even algebraically, it's n factorial over k factorial, n minus k factorial. So they are going to be the same. This reason seems very weird, but I'm still stuck after practicing many problems. Anything I'm missing? I answered this in the video that will be released very soon. Choosing n people for a team is the same as rejecting n minus k people. Exactly. Exactly. So that's right. So when we have n people and we want to choose a team of k people, that's the same as rejecting n minus k people for that team. So the question this time is going to be, we have n people. We want to have a team of k people. So in one way we can solve it by this. Let's select k people. This gives us n choose k. In another way, we can say that let's reject n minus k people. This gives us n choose n minus k. So these two are the same. N choose k and n choose n minus k are going to be the same values. And also you can see that you can easily say that the formulas are the same as well. For example, this one formula is n factorial over k factorial n minus k factorial. It's not even algebra. It's like, okay, the formulas are the same. So it was obvious from the beginning. But now let's do a problem that is actually challenging. And you're gonna enjoy how applying combinatorial solution can solve this problem. Let's calculate sigma of I from 0 to n choose I squared. What is that? Sigma of I from 0 to n choose I squared. I will release the video probably today or tomorrow. It's in final state of editing. So if it just that minor issues gets resolved, my editor is working on it. If he resolves the final minor issues, I will release that. So we want to now calculate sigma of I from 0 to n choose I squared. How can I solve it? What is the number of ways, the answer. Any ideas from your side? 2n choose n. Why? Why should this be equal to that? 2 to the power of 2 to the power of n. Again, why? I won't give a comment on whether it's correct or it's not correct. Just why? What's your view on OpenAI O3? Is it performing 99.8 percentile of competitive programmers? Well, OpenAI itself has said that, argued that the rating of O3 is 2300 in their live stream. 2 to the power of 2n. Okay, let's say what we can do in here. First of all, I'm gonna make a small change. I know that n choose I is equal to n choose n minus I. Exactly. N choose I is equal to n choose n minus I. So I will substitute one of them. So I will have n choose I times n choose n minus I. So first of all, I say that n choose I squared is equal to sigma of n choose I times n choose n minus I. Now what you have to do is to just think, how can you define a problem such that its answer is equal to this? If you define a problem such that its answer is equal to this, maybe then you can solve that problem in an easier way as well and get an easier, more simplified solution, a closed solution, not without having a sigma. So just try to think, how can we define a problem such that its answer is this? Its answer is sigma of I from 0 to n, n choose I times n choose n minus I. How can we define a problem such that its answer is n choose I times n choose n minus I? I'm giving you the chance to think about it and share ideas. Any ideas? For a problem such that its answer is this. Each term is the same as, yes, that's right. Could you launch a course from basic to advanced for CP? Please don't say soon. Definitely, I will launch a course. I'm working on it. Probably my first course can even be on Combinatorics itself if you want. Or it can be on DP. But as we discussed before, most of you guys prefer to have several small courses rather than a long course. We can do that definitely. So that you wanted to have several small courses so that you can choose which ones of them you want and only get them. But yeah, I will launch a course. Again, combinator. You really hate combinators, I guess. Making a team of n people from 2n people. Exactly. That's a very good question. Exactly. Where are you from? I guess from the same place that you are from, Ilya. Where are you from? Number of ways to choose a subset and complement. Yeah, that would be great. Yeah. So, yes, I say that, let's say I have n boys and n girls. And I want to choose a team of n people. I want to choose a team of n people. How many ways do I have to do that? I say that I will fix that how many boys I will choose. I either choose 0 boys. In that case, I'm gonna have to choose n girls. So it's gonna be n choose 0 times n choose n. Or I choose 1 boy, in which case I have to choose n minus 1 girls. Or I choose 2 boys, in which case I have to choose n choose n minus 2 girls. I mean n minus 2 girls, so it's gonna be n choose n minus 2. Let's move it a little bit. Or I'm gonna choose n boys, in which case I have to choose 0 girls. So it's gonna be n choose n times n choose 0. So I showed that the answer to this question, when we have n boys and n girls, and we want to choose a team of n people, it's gonna be sigma of I from 0 to n choose I times n choose n minus I. And boom, that's the same thing that we were looking for. So now the question is, can we solve this problem in an easier way as well? Exactly. So that's 2n choose n. Because we are, at the end of the day, we are choosing n people out of 2n people. It doesn't matter if they are boys or girls. There are 2n people and we want to choose n of them. So the answer is gonna be 2n choose n. Therefore, this is gonna be 2n choose n. That's it. So at the end of the day, we have n boys, n girls. We have 2n people. Let's not be sexist and say, okay, we have 2n people and we want to choose n of them. So it's going to be 2n choose n. So we defined the problem such that its answer was equal to this. And then we solved it in another way. We said that, okay, in a simpler way, we can say that it's equal to 2n choose n. How you are able to come up with problem example, I couldn't think of any. I saw these problems before, and these were the best problems that exist from this. It's really interesting. Yes, if you understood it, put a plus or use this emoji. These type of problems are one of my favorite type of problems. What happened in the ICPC World Finals? I would expect your team to do better. Yes, we expected ourselves to do better as well. Everyone expected us to do better. It was unbelievable how it went. Both for me, for Colin, for Sam also. It was very unbelievable. Which country are you from? Which country am I from? That's a good question. What do you think? How do I look? If you want to judge my country based on my look, where do I look to be from? I also asked this question from ChatGPT. Maybe I can ask this question from ChatGPT right now. So let me to just have a short break as well so that your mind can rest. Let me take a photo of myself right now. Okay, it's taking a photo from me from iPhone camera. Where is this person from? Give me 10 choices, 10 answers with their probability, with their respective probability. I just want you to predict. I did it once when we had a AUA with, we had an AUA with UMD team before ICPC. That didn't go well. Cheater GPT. No, I don't think so. Iran Bozorg. Egypt. I don't think it can find out about me. It understood. Based on prediction alone, here are 10 possible origins for this person. with estimated probabilities. Iran 40%, Turkey 15%, Lebanon 10%, Syria 8%, Pakistan 7%, Iraq 6%, Egypt 5%. How could you predict what kind of details helped you to figure out? It's a bit weird that it could understand that Iran is 40%, because last time that I tried, Iran was its second choice. But now that it's understood, it's interesting. Facial features and hair type, nice. The person has thick, curly, dark hair and a beard, which are common features in populations from the Middle East, North Africa, and South Asia. Facial structure, skin tone, and hair texture can hint at regional ancestry, though they're not definitive. T-shirt details, ICBC and sponsor. How's that related? The T-shirt has ICBC branding along with its sponsors, Jane Street, JetBrains, Citadel, etc. ICBC is popular word, but has a strong presence in countries with competitive programming cultures like Iran. Come on. It's also used. My IP address is from the US, so my IP address is from the US, so if it could, it wouldn't say that. But the second, yes, the second reason is really wild. It says that because you have an ICBC t-shirt and countries with, Iran is a country with competitive programming culture. That was super smart. That among the Middle East countries, Iran is the one that has the culture of competitive programming. That I really didn't think that it can think about that. That was really super smart that it was thinking about that, and it also included that in the argument. Writing and wall decoration. Come on! Writing and wall decoration. There is a Persian or Arabic script on the left side of the image, suggesting that the person may come from a country where these scripts are used. Where have I wrote something in Persian? The first going from noob to expert hints at Combinatorial or YouTube education channel, which is quite common in Iranian and Indian CP communities. That's weird. I don't think so. YouTube is not common in Iranian. Medal and plaque on the wall. Achievement in the campus program academia. Countries with a strong activity percentage such as Iran, Russia, and India came to mind. Lighting and setup. Come on! At the end it says that, given that I know you, Cheyenne, are Iranian. Okay, so this is funny because all the time it's told us all these reasons, and at the end it told that, given that I know you. It was so it told us all these reasons at the end. No, it is not Cheyenne. Predicts again. Yes, I believe that ChatGPT is trolling us. Since it's not you, I'm saying that it is not Cheyenne. Predict again, and it responds me at alright, since it's not you, so it knows it's me. And it's like, okay, since it's not you, I release the prediction again. What is the S script though? ChatGPT is really trolling us. It's really trolling me. It told me all these reasons, and the sixth reason was that, yeah, I know you. You're Iranian. Okay, what do you see on the wall? Tell me the sentence. but I can make an educated guess based on what I see. Okay. So, yes, since it's not you, exactly. Okay, AI is going wild. It is starting to troll human beings. It's scary. Yes, it's scary that AI has learned to troll us. And even when I tell it that it's not Cheyenne, it says that okay, it's not you. It's like, yeah, okay, it's not you. Okay. Okay, let's continue. So it was fun. It was a nice break. Let's continue and get back to our discussions on combinatorics after being trolled by ChatGPT. So AGC allowing AI in during the contest. What is AGC? I don't know. That's in. I think sooner or later they should allow it because everyone have access to it, and at least when they are training, they have access to AI, and so I kind of believe that at some point they should allow it, like the way how they allow it to use a calculator in the exams, because that's the tool that people have. So when ChatGPT and AI grows in the real world problems, we have access to AI. So in practice, after a while, it's good to have access to AI as well, and like the way we have access to calculator. So I think that maybe in future, you should have access to it in long future. But I don't know how the contests are gonna look like, how you can make new problems such that AI cannot solve them, but it can only help you. Oh, Atwiller Grant contest. I see. Okay, Atwiller Grant. I was thinking that you're talking about an on-site contest. Yes. AGC, I think because they know that people have access to it, then they can't do anything. So they said that, okay, let's let it. Okay. Let's continue. Yes. So let's continue talking about our topics. There are also more things to discuss about what is equal to what. There are more interesting problems. If you want, I can do that, talk about them in another topic streams, or I can teach it in a course on combinatorics. Probably I can make a course on combinatorics and talk about the rest as well there. But now it's better to move on to the next thing because we have more things to discuss. Next thing, I want to talk about how to calculate combination. We want to calculate combination. Well, first of all, let's say that we have n and k. We have q queries. Q is up to 10 to the 6. And we have n and k up to 1,000. And each time we are given n and k, and we have to answer what is n choose k modulo what. We have to give n choose k modulo what. What can we do in this problem? Help me with that. What can we do with this problem? So we have q up to 10 to the 6. Each time we are given n and k, and we have to say that's what is n choose k modulo what. Is it still beneficial to do CP? Yes, I believe it's still beneficial because I believe that at least in the... We can't be sure anyway, but I believe that still human mind is gonna be important. And still maybe like how some people say that AI is always a tool and at the end you need some human being to do things. AI can only help human being. I think that's something that if it still is important for humans to think CP is important. Exactly, we can use Pascal triangle, Pascal triangle, the Pascal equality. We can say that, let's say Let's use Pascal triangle and say that, and we know that n choose k is equal to n minus 1 choose k minus 1 plus n minus 1 choose k. So we can use the dp. We can use dp. I again strongly recommend to you to watch the topic streams on dynamic programming. In here we can use the dp. Let's define an array C of I and j, which is I choose j. We can easily just say that C of I and j is going to be C of I minus 1 and j minus 1 plus C of I minus 1 and j. C of I minus 1 and j minus 1 plus C of I minus 1 and j modulo mod. So, and also if j was equal to 0, that's our base case. C of I and 0 is always 1. The number of ways to choose 0 from something is 1, always. Always I choose 0 is 1. Okay? So this way we can pre-compute these values, we can pre-calculate them and store them somewhere. And each time that we are given n and k, we just return n choose k. We will just see out C of n and k. So that's how this problem can be solved. Now let's move on to the next thing. Let's say that again q is up to 10 to the 6th, but now n and k are up to 10 to the 6th as well. Now how can I solve the problem? How can I return n choose k for each values of n and k? This topic stream is from scratch. I talked about everything, but definitely watching the previous topic streams helped, especially the number theory ones, because you have seen these things before. And I will also tell you that for more details, you can watch some topic stream to see what is going on. Exactly, we can use Fermat-Leader theorem. If you have watched number theory number 2 topic stream, we have something called Fermat's Leader theorem. The T at the end of it is silent. Fermat's Leader theorem. What does it say? It says that for a prime number like p, for a prime p, and some number a from greater than 0 and less than p, a to the power of p minus 1 is equal to 1, is congruent to 1 modulo p. A to the power of p minus 1 is congruent to 1 modulo p for a prime p. And that's why usually in the problems your mod is prime. You see that always your mods are like 10 to the power of 9 plus 7, 10 to the power of 9 plus 9, or that's some other prime numbers. It's always a prime number. You always see that it's a prime number. What's the reason? One of the reasons is that so that you can use Fermat's Leader theorem. So how this Fermat-Leader theorem is important. For more details on why Fermat-Leader theorem, why is it true? For more details about Fermat-Leader theorem, let me share to you the second topic stream on number theory as well. I recommend to you to watch that. You can go to topic streams here and watch the second video on number theory in here. Number theory number 2, exponentiation, Fermat, and combination. I've talked about these topics. So for more details, you can watch that. But anyway, in here we just use it. We just say that a to the power of p minus 1 is congruent to 1 modulo p. That's always true. Let's take an example. Let's say that p is equal to 5 and a is equal to, for example, 2. A is 2. So in here, a to the power of p minus 1 modulo p must be congruent to 1. So let's see if it is or not. What is a to the power of p minus 1 is 2 to the power of 4, which is 16. And we see that modulo 5 is 1. So it works. This was just an example. It's also true for other things. For example, you can change your p to 7 if your p is 7, 2 to the power of 6 must be congruent to 1 modulo 7. 2 to the power of 6 is 64, and 63 is divisible by 7. And you see that it really is congruent to 1. So Fermat theorem is always correct for a prime number p and the number a between 0 and p, greater than 0 and less than p, because if it's a multiple of p, a should not be a multiple of p. Anything else works. But usually we use it for a between 0 and p, greater than 0 and less than p. If it is a multiple of p, a modulo a to the power of anything is 0 modulo p, other than a to the power of 0. So it shouldn't be a multiple of p. A shouldn't be a multiple of p, but it can be anything else. So a to the power of p minus 1 modulo p is going to be 1. Now, how is it useful? The point is that when you want to divide two numbers, two big numbers, that we have the modulo mods, we cannot just say that, okay, a divided by b. We cannot write 8, use division sign, and then b. We cannot write it like this because they are not actual values. They are the values modulo some mod. So the point is that when you want to calculate a over b modulo some mod, and you have a modulo mod and b modulo mod, you can say that this is equal to modulo mod is congruent to a over b times b to the power of mod minus 1. Since mod is a prime number, a over b is equal to a over b times b to the power of mod minus 1. Because this is 1 modulo mod. This is 1 modulo mod. This is congruent to 1. So we can multiply it. And therefore, a over b modulo mod is going to be equal to a to the a times b to the power of mod minus 2. So when we want to calculate n over b, we can say that it's equal to a times b to the power of mod minus 2. And how can we calculate b to the power of b minus 2? We just talked about power at the beginning of this topic stream. We just saw that how can we calculate power in O of log of the power. So it's going to be O of log of mod here. We can exponentiate in O of log. So yes, and it will only work if your mod is prime. Exactly. Otherwise, you have to learn Euler's phi function. Exactly. We can discuss that in the future too. So now, when we want to say that what is n choose k, what we can do is this. We can pre-calculate all the factorials of the numbers from 0 to n. We can calculate all the factorials. Fact of 0, 2, fact of your max n. I show it with capital N minus 1. So I calculate all the factorials, and I can say that n choose k modulo mod is gonna be equal to fact of n times fact of k to the power of mod minus 2 times fact of n minus k to the power of mod minus 2. So this is gonna be our answer. N choose k is gonna be this times this times this. These two values can be calculated in O of log, and we have this value as well. So we have to multiply three numbers, and we have to also be aware of overflow and make sure that we are calculating it modulo some mod. Okay, we have to make sure that we are calculating it modulo mod. So this way we can calculate n choose k using Fermat's leader theorem. Is it completely clear? If it is clear for you, please again put a plus or use this emoji. And if it is not, let me know. What could be the optimal way to calculate n choose 0 plus n choose 1 plus n choose 2 plus 2 n choose k? We can think about that then. For now, I have the only thing that comes to my mind is to have a 4, is to iterate. I don't have any, I'm not sure if there's any better solution. But we can think about that. Okay, so let's get back here. So in here we have some pre-calculation. We have some pre-calculation. And we also have some query time. I want to create a table to see that what is the time complexity in our pre-calculation and what is the time complexity in our query time. Right now, how much does our pre-calculation take time? What is the time complexity of our pre-calculation? I want to calculate the time complexity of our pre-calculation and query time. Our pre-calculation exactly is in O of n. And for each query, how much time do we spend? What is the order per query? Yes, that's right. I start to discuss on this. It goes like this. I hope that it doesn't have sound though. Exactly, it's gonna be log of mod. No, not log of mod to the power of 2, log of mod. Because these two are independents. We calculate this independent of this. They are two, it's mod, log of mod plus log of mod, not times log of mod. So it's gonna be, yes, O of log of mod per query. So in total it's gonna be, right now, I write log of m in here. So right now it's gonna be O of n plus, let's say that, let's write also total in here, considering q as well. It's gonna be O of n plus q log of n. Well, I don't like it that much because we are answering each query in O of log. I don't like it that much. I want to be able to answer each query in O of 1. And it doesn't matter if our pre-calculation takes more time. I don't care if my pre-calculation takes more time, as long as it doesn't get time limited. How can I make my query time faster? Even if that makes my pre-calculation worse. How can I make my pre-calculation, how can I make my query time faster? I want to answer each query in O of 1. How can I do that? So I want to answer each query in O of 1. How is that possible? You could also pre-calculate inverse of factorials. Exactly. Well, in general, the name of this, for example, b to the power of mod minus 2 is inverse of b. Modulo mod, we call that the inverse of b because it's like b to the power of minus 1. Right? So we call it inverse of b. That's what anonymous means by inverse. We can pre-compute all these values. We can calculate also some other array, inv of I, or I fac of I, which is equal to the power of fact of I to the power of mod minus 2. We can pre-calculate all these values. And what does it give us? This way, in here we can change these because we have already calculated the inverses. Because we have already calculated the inverses, we don't need to raise them to power anymore, and we have them already. But we have spent some more time in pre-calculation. So now what is the time complexity for our pre-calculation? What is the time complexity for our pre-calculation? Now. What is our time complexity for pre-calculation? Yeah, I talked about that one. I think we have also discussed it before too, right? So anyway, what is the time complexity of pre-calculation now? I think now we have some delay. No, right now. It's n times log of mod, exactly. And what is the query time? It's n log of mod, n log m. The query time is O of 1. Yes. So it's going to be O of n log m plus Q. This is way better than the previous one. This is way better. Why? Because each query will be answered. Each query will be answered in O of 1 this way. And the point is that why is it better? In this case, Q and N are both up to 10 to the power of 6. So why is that better? Well, the reason is, in this case, Q is up to 10 to the 6, and it's the same as N. But in general, we know that we are just changing our pre-calculation, and it doesn't give us TLE. Pre-calculation just happens once. It doesn't give us TLE. So it's not much different if we do it in O of N or in O of N log of N. But sometimes you have so much calculations, and if in all of those calculations we multiply an additional log, it's going to be problematic. For example, assume that our order, our time complexity already is n log. This way, by doing this, we are adding an additional log to that as well. But we don't want to do that. So the point is that it's better to spend more time at the beginning to pre-calculate. And it's okay, it doesn't get a time limit. N log m never gets time limit, so we don't care about this. It's just some milliseconds difference between this and this. So it doesn't make any issues. But if we multiply log by Q, that can cause us issues. Why? Because maybe in a problem we need to make so many calculations to calculate, so many times we have to calculate the n choose k for different values of n and k. So this second solution is way better. And now I want to also discuss if can we solve it in a way that both of them will be of 1. So our pre-calculation will be of n, not n log m, and also our query time will be of 1. So the best of each it's going to be of n in pre-calculation and also of 1 in query time. Can we do that? Just today I got TLE just because of a factor of 10 TT. What is 10 TT? Can we, now my question is this, can we somehow do the pre-calculation in O of n and solve each query in O of 1 or not? Oh, that's crying emoji, I see. Because of a factor of 10, I see. So what is your idea? How can I calculate in fact? I want to still calculate in fact, inverse of factorials. But I have to raise them to some power. I have to raise these factorials to some power to calculate their inverse. So how can I skip that and somehow calculate the inverses in of 1? N minus 1 inf is inv of n times n. What do you mean? Like dp? Yes. So my idea is this. Well, first of all, there are two solutions. First is that we have a formula for inverse. Okay, let me tell you the formula as well. Maybe it can help you. Let me ask ChatGPT in front of you guys. What is the formula for inverse of n factorial modulo mod? We want to calculate in CPP all the inverses of the numbers from 1 to 10 to the 6. Well, this is not our solution. This is not what I want to tell you. But I'm saying that there's also a formula as well for that. So it's saying that Fermat leaders are, I to be honest want to see if it can solve it as well or not. Let's use O3 mini high. I want to see that how does it answer and if it gives us the formula as well. My solution is without any formula. I'm not going to use any formula. I'm going to have a very interesting idea. Okay, it's also suggesting us the interesting idea. Okay, it gives us the interesting idea, but also gave us the solution that uses the formula. Then calculate the other inverses relatively. Alternatively, we use a recurrence to compute the inverses. Inv of I is equal to mod minus mod divided by I times inv of mod modulo I mod mod. Explain this in detail. ChatGPT solved it in both solutions. I mean, both of the solutions that I wanted to tell you, both the neat way and the way that uses a formula. But now I want to only talk to you about the formula, and then I'm gonna tell you the main solution that doesn't use any formula. We don't need to memorize anything. This formula works when mod is either prime or an integer. To understand, use identity for I greater than 1. ChatGPT can do everything and solve such a complex problem, but it cannot render this math. You see, it's not rendered. The formula is this. The formula is that inv of I is equal to mod minus mod over I times inv of mod modulo I. And what is the reason behind that? The reason behind that is that we can say that mod is equal to I times Q plus some R. And then it says that. Let me ask it to render it well. But the point is that I seen this for the first time in someone's code, and it looked so interesting to me, this thing. And I started thinking about it to see that what is the reason behind this. And then I also came up with that easier solution. And then I didn't need this anymore. But I remember that when I saw it in a code, I was trying to understand why is it true, and it was also interesting. But still it's a formula, so it's not very good. So it just tells you something about the formula, about how it works. It writes something and gives you that, it's telling you that why is it true. But you can also think about it as well. It's a good exercise to think about. You can try to think about it as well. That can be a good exercise to think about. Although you do not really need it that much, as I never used it afterwards as well. I just used it that once or maybe a few times very close to that, but after that I was using this neater solution. And what is that neater solution? The neater solution is this. Let me just go back to the neater solution. So we had a formula for it. The formula was that fact of I, when we calculate factor of I, inv of I, as ChatGPT also said, is equal to mod minus mod over I, floor of mod over I, times inv of mod modulo I modulo mod. You can think about it, about why is it true. As I said, I remember that the first time I saw this, I was thinking that why is it true, and it wasn't that hard. I got to the point. But let's talk about a better solution as well. The better solution that is more intelligent as well is this. Instead of going forward and calculating inv of i's, let's calculate inv of n minus 1. inv of the maximum value. What is it? Is PW of fact of n minus 1 to mod minus 2. But what? We just said that we don't want to do these powers. We didn't want to do these powers anymore, because that way we're gonna have a log factor. So why are we using this power? Well, the point is that we are only using it once. We are not using it every time. We are only using it once. And then we say that we go backward instead of forward. We will go backward. And we assume that we already know inv of I plus 1. Inv of I plus 1 is known. And I want to calculate inv of I based on that. So what is inv of I plus 1? It's I plus 1 factorial to the power of minus 1. It's congruent to inv of, is congruent to I plus 1 factorial to the power of minus 1, or 1 over I plus 1 factorial. Is congruent to this. Now I want to calculate inv of I. What is inv of I? It's 1 over I factorial. So we had 1 over I plus 1 factorial. We want to change it to 1 over I factorial. So what should I do to change 1 over I plus 1 factorial to 1 over I factorial? How can I change it? How can I go from 1 over I plus 1 factorial to 1 over I factorial? Well, the point is that you can just multiply it by I plus 1. Well, do not forget that what was the concept behind inv of I plus 1 and inv of I? Inv of I was 1 over I factorial modulo mod. So inv of I is 1 over I factorial modulo mod. When you know this, you can just say that, okay, you know that what 1 over I plus 1 factorial is. Then 1 over I factorial is all, as we know that 1 over I factorial is 1 over I plus 1 factorial times I. So, times I plus 1. So, inv of I is inv of I plus 1 times I plus 1 modulo mod. That's all. We have to multiply 1 LL as well, so that we won't have overflow. So that's all. We go backward and we say that inv of I is going to be I plus 1 times inv of I plus 1 modulo mod. Exactly. Azizbek Marul Fi Junov. Are you from Uzbekistan? Azizbek or Azerbaijan? You're from Uzbekistan. Cool. Nice. I feel proud that I could guess your nationality based on your name. I'm better than ChatGPT. I have no idea what's going on. Feels like an... Okay guys, give me some feedback. Did you understand it or not? If you understood it, put a plus, otherwise put a minus. And it seems like I'm running out of charge as well. That's the bad news. Guys, did you understand it or not? If you understood it, put a plus. If you didn't, put a minus. Also, you can use this emoji if you understood it. So the previous thing that I said, let me repeat it, because I know that there might be several people who didn't understand it. There are several people who haven't understood it. So I said that, first of all, I said that there's a formula to calculate inv of I in O of 1. There's a formula. But I'm saying that, again, we don't like formulas. We don't want to memorize complicated things. Even though we can talk about why is it equal to this. I can talk about it in another topic stream or in a course about combinatorics as well. But anyway, we have this formula to calculate inv of I. But other than that, we can also say that let's calculate inv of n minus 1. Let's calculate inverse of the last number and then go backward. What is inv of I? Inv of I is 1 over I factorial. So if I know 1 over I plus 1 factorial already, 1 over I factorial is going to be 1 over I plus 1 factorial times I plus 1. Hence, I can just say that let's multiply inv of I plus 1 by I plus 1. This is going to be our final answer. Okay, so I start from the end and I will go backward. Now if we do this, our total time complexity will be this. We have O of log at the beginning to calculate this power, and then O of n to calculate all the inverses. And n is greater than log of m. Come on, log of m is like 30 at most. 30, or it's less than 100. N is more than that, so it's O of n. So it's our pre-process, pre-calculation is O of n, our query time is O of 1. So in total, our order is going to be O of n plus q. Also, if we use this formula, it's going to be, I mean, to be more precise, in this way, our time complexity is going to be O of log of n log n plus log m, n plus q plus log of m is plus log of m, not multiplied by log of m, because we do it only once. But if you use the formula, it's n plus q. But the point is that this solution is the same as this solution. Really, it doesn't make that much change, because the important thing is the query time. Pre-calculation part is not that important, because you do it once and you're over it. You do it just once. And the point is that you don't get a time limit if you do n log instead of n. So these two solutions really do not differ that much. But this one differs a lot with them, because in this one you are multiplying a log to everything that you're calculating. But in these two solutions, you do every calculation in O of 1. Okay. I hope that it's now clear for everyone. If you have any questions, let me know. Now we want to solve a problem as well, and it's a very interesting problem that we want to discuss. I feel so hungry too. I feel kind of nauseous. I just woke up and came to the stream. I didn't eat anything. I kind of feel nauseous right now. But it's okay. Let's continue. So, if you have no questions, let's move on to the problem and discuss it. So, the problem that we're going to discuss is this one. 1040, no. I'm trying to get it back. It's not 1043F. It's 559C. This one. And please let me to bring the charger as well. Please let me. Okay, so I won't lose my charge, my battery won't die now. It's because it had less than 10% charge. It's 10% now. Okay, so the question that we want to talk about is 559. See this one. What does it say? It says that assume that we have a giant chess. And it's like this. We have a field of h by w. Its size is h by w. H and w are both up to 10 to the 5th. And n cells, all of these cells are blocked. Let me explain it in the tablet. So assume that we have a chessboard of size n by k. Sorry, h by w. I don't know why I said n by k. We have a chessboard of size h by w, and h and w are both large. They are both up to 10 to the 5th. And we want to block several cells. The several cells are blocked. And we cannot go inside them. And we want to start from the top left corner. We want to start from this top left corner and go to this bottom right corner. And we have to say that how many ways do we have to go from this top left corner to this bottom right corner in such a way that each time we will either go to right or go to bottom, go downward, go rightward or downward each step, and we will never go to a blocked cell. So each time we have to go either to the right or rightward or downward, and we don't want to go to a blocked cell, and we want to get to this bottom right cell. You have to say that how many ways do we have for that. And okay, how many ways do we have for this? Well, the point is, I keep repeating the point is so many times and it's annoying myself. We can say, yeah, one way is inclusion exclusion, but there's also a more beautiful way as well. There's also a more beautiful way. And what is that way? I'm saying that let's answer this question. Let's also define an imaginary blocked cell at the end. Let's say that assume that this cell is also blocked. This is a special blocked cell as well. H and W are up to 10 to the 5th and N is up to 2000. H and W are up to 10 to the 5th and N is up to 2000. So what I can say is, let's define dp of I as the number of ways to start from the top left corner and gets to the blocked cell number I such that we won't go to any other blocked cells. So dp of I is gonna be the number of ways to go to the blocked cell number I in a way that we won't go to any other blocked cell. Okay. If H and W were up to 100, that's a good question. If H and W were up to 100, yes, we could do it in of H by W. Because each cell could be the sum of its upward cell and leftward cell. The number of ways to come to here is going to be the number of ways to come to here plus the number of ways to come to here. And if it is blocked, the number of ways to get there is 0. So if it was blocked, the number of ways to get there is 0. If it was not, it's going to be the sum of the upward and the leftward cells. If H and W was up to 100. But in here, because the solution is going to be of HW that way, it wouldn't work in here because H and W are 10 to the 5th. So what can we do instead? Instead, I'm defining another dp. dp of I is the number of ways to get to the blocked cell number I if we start from the top left corner and we don't visit any other blocked cells. And when I want to calculate dp of I, how do I do this? I say that what is the number of ways if we ignore about the fact that we don't want to visit any other blocked cells? In how many ways I can come to here from the top left corner? How many ways do I have to get to here from the top left corner? Assume that the coordinate of this cell is 1 and 1 and the coordinate of this cell is I and j. How many ways, if I don't care about the blocked cells, how many ways do I have to come from 1 and 1 to I and j? Exactly, it's I plus j minus 2, choose I minus 1. Exactly, because in order to get here, we have to do I minus 1 rightward moves and j minus 1 moves downward. So we have to do I minus 1 rightward move and j minus 1 downward moves. And we can have any sequence of them. We can have any sequence of I minus 1 rightward moves and j minus 1 downward moves. And the point is that we can choose those I minus 1 downward moves from this I minus 1 plus j minus 1 total moves. So it's going to be I plus j minus 2, choose I minus 1. This is going to be the number of ways. It's going to be I minus 1 plus j minus 1, choose I minus 1. So this is the total number of ways. So first I defined my dp as this. Let's erase this so that this I won't get conflicted with this I. So first I define my dp as this. I set my dp as this value. X of I plus y of I minus 2, choose x of I minus 1. And then I want to subtract all the ways that I will visit another block cell before this block cell. I want to subtract all the other ways that I will visit another block cell before this block cell. How can I subtract them? Well, the point is that in any bad way that we will visit some block cell, there is some other block cell that you will see that one first. So I might go to a path, I might start a path to come here in which I start several block cells. But I'm saying that among those block cells, there's one block cell that you will see that one first. Okay, for example, if I come from this path, this is the first block cell that I will see in my path. So I will iterate over the first block cell that I'm gonna see in a bad path that I'm gonna visit at least one block cell. I will consider the first block cell that I will see. I will consider this first block cell that I will see. And let's call it cell number J. So I will have a for J among all the previous cells. Assume that I have sorted the block cells by their xi first, and if their xi was equal, then by their yi. This way, all the cells that can be before this cell their dp's are calculated before this one. And then in how many ways this cell is the first block cell? The number of ways is gonna be dp of j times the number of ways to go from j to this one. Why? Because the number of ways to get here is dp of j, because this is the first block cell that I see. So I have dp of j cells, because before this one I should not go into any other block cell. And then the point is that after that, it doesn't matter if I go to a block cell or not. This one was the first block cell. After that I might go to other block cells as well, or I might not go to any block cell. But this one was the first block cell. So I will multiply it by the number of ways to go from j to I, which is going to be again x minus I minus x minus j plus y minus I minus y minus j. Choose x minus I minus x, choose I minus x, choose j. Sorry, what did I say? X of I minus x of j. So it's gonna be, because I'm gonna have x minus xi minus xj rightward moves and yi minus yj downward moves, and I'm gonna choose that where are gonna be those downward moves, for example. So I will multiply dp of j by this, and I will subtract that value from dp of I. This way I can calculate the number of ways that I can get to I without visiting any other block cells. And my answer is going to be the dp of the last one. As I said, I've added an imaginary block cell at the end. And whatever the answer to that one is the number of ways to get to the bottom right cell without visiting any block cells. Is it clear? And I know that this bottom right cell by itself is never blocked, so it's going to be okay. How many you can reach to top and left cell? I'm not sure if this is the answer to something that I asked, or this is a question. If any of you guys had any question, you can ask me now. If you understood it, put a plus or use this emoji. Why can't there be any ties in first block cell reached? Well, definitely it's not, because we have a path. We have a path. We are going through a path. Just consider the first time in this path that we reach a block cell. It's not, at each time we are in one cell. So it's not like we can be in the same block cell at the same time. There will be two block cells such that we are in both of them, and both of them are blocked, and so there's a tie in the first block cell. We always have a path at each time we're in a block cell. So the first time that we visit a block cell, is always going to be unique. But why consider only first block cell? Like it can miss first block cell and hit second. Yes. I'm saying the first block cell that it see in its path. I have a for on all such, and maybe there's also another path. For example, this path will be also calculated. In this path, the first block cell that we visit is this one. I'm saying the first block cell that we will see in our path. So also, if this is k, also dp of k times the number of ways to go from here to here should be subtracted. This is not the first block cell that exists. I'm conditioning on the first block cell. I'm conditioning also this cell can be the first block cell in this path, for example. In this path, let's make it bolder. In this path, this cell, this blue cell, is the first block cell. So I have to also, I call it k, I have to also subtract dp of k times the number of ways to go from that block cell to this block cell. So it's not the first block cell that exists. It's the first block cell in the path that we want to subtract. So all the passes will be subtracted somewhere, will be subtracted in the first time that they will reach a block cell. So this way all the bad passes will be subtracted. Is it clear now? Or is it not? If it is, please again put a plus or use this emoji again. What if some path is common between two block cells? It's not. Well, the point is that each path can visit several block cells, but only one of them is the first one that is blocked. For example, if you consider any path, from here to here, it might visit several block cells in its path. I'm saying that let's consider the first one of them and only subtract it in the first one of them. It might, for example, visit several block cells like this. But I'm saying that I'm only calculating this bad path only in here. Because I'm saying that let's just count it in the first block cell. It won't calculate it in any of the other ones. Because I make sure that in order to come from the top left corner to the first block cell, I will not visit any other block cells. That's why I use dp of that first block cell. Awesome. Ali Khazr, is it clear for you now or not? And about the rest of you, if it is use this one or use the emoji or say it in the chat. I will repeat it once again anyway. So I'm saying that I consider all the passes to this cell. I want to subtract the passes that won't work for me. I will subtract the passes that they will visit some of the block cells. What can I say about those bad passes? They are gonna visit some block cell for the first time. They're gonna block some block cell. They're gonna visit some block cell anyway. So I'm conditioning that. What is that first cell that is gonna be blocked? I will condition on that. And then I say that I count the number of ways to go from this top left corner to that one, such that I won't go over any other block cells, and multiply that by the total number of ways to go from here to here. And this way I can calculate the final answer. I multiply it by the total number of ways to go from here to here. Okay? And this way I can calculate it. Is it clear now? And again, guys, if in case you like this topic stream, this live stream, and it's not gonna be hard for you or you're not against it in any ways, I would appreciate it if you come here and just play this like button. I mean, not play, press this like button. I think that that helps this video to be seen by more people. Also, I would appreciate it if you share it, or if you can, if you really want to support this live stream, what else you can do, you can come inside the comments here. I think right now they're off. The comments section is off because we're during the live stream. But in case, only in case that you're okay with that, it's not gonna take your time or it's not gonna be hard for you, you're not against it in any way, you can write a comment about this topic stream. I think that's also be very supportive. Thank you very much, Anonymous. Okay, I think that's all about this topic stream today. I hope that you learned something from it and it's worth how you waited for this one and how it took your time. I know that it got cancelled once before and I'm really sorry for that, and it was delayed today as well, but I hope that at the end it's worth it and it helped you guys. So if you have any questions about this topic stream, you can tell me. As I told you, I will release the video hopefully today, hopefully today. Right now it's our morning, maybe it's gonna be your tomorrow morning, but I hope that I can release the video today on how to get to expert. I will definitely let you know in the Telegram channel, and also in YouTube you can see that as well. Probably I will write a blog post in Codeforces too. Yeah, I will write a blog post in Codeforces too about it. Thank you guys a lot for joining this topic stream. I'm gonna put a poll. Let me also again share the links to the Telegram channel. I'm gonna put a poll again there to see what you want the next topic stream to be from, and then we will set a time for that too. Probably I think Monday can be a good option probably. Thank you all, and sure thing. Great, nice. So see you guys next time. Bye bye for now.